In this video, we're going to take a look at getting started with object-oriented programming, and it's all about knowing the basics. When you get started with object-oriented programming, often abbreviated as OOP, it can seem very overwhelming at first. Sometimes you don't even know where to start. Well, you want to start with the basics because once you understand all those terms and the phrases that people use, it allows you to master the concept of object-oriented programming not only faster, but it makes it so much easier. Now, you may be coming from a different programming paradigm, and that's usually it's procedural. You're going to write a set of procedures and functions to handle everything. You have some global variables, maybe some local variables. In object-oriented programming, it's a lot different. So you're going to have to switch up how you think about writing code. That doesn't mean it's harder. I actually prefer object-oriented programming than other paradigms because it's much easier to use once you master the concept. Now, the basics you need to know are the following. Now, these are the basics, and they are the foundation. They are the bread and butter of any object-oriented program. You have classes, you have objects, you have attributes, you have constructors, and then you got to think about what should be public and what should be private. If you can understand those basics, know what they are, know what they do, you will be on your way to mastering object-oriented programming. Now, it's all about knowing what the terms are so you can understand the code, because looking at code, when you don't know what the terms mean, make it impossible to even analyze that code. Well, if you don't understand the code, you can't analyze the code and you cannot create code. Now we're going to go through these terms. We're going to take a look at code to see how it looks when it's finally written. So we're going to go over all these terms and we're going to write it in code so you can see what it actually looks like. So when you see it again in the future, you know exactly what it's doing. And it all starts with a class. You cannot create an object without a class. Now, a class is a blueprint for the object. So when someone says you need to create a class for the object, what they mean is you got to create a blueprint for the object. Now, a class has attributes, which is the characteristics of the object. It has a constructor or constructors, depending on how many parameters it takes, which we'll get to in just a little bit, and various methods that allow the object to do something or allow you to do something with the object's attributes. Now, the class should always follow the is-a relationship. When you have an object and you're trying to figure out what class it belongs to, as you start to get more classes, you want to follow the is-a relationship. So here's how you do it. You take the object, whatever it may be, is-a, and then the class name. Now remember, your class name should have no spaces. You're not allowed to have spaces, so that's why I put with no spaces. Here are a couple examples. Batman is a superhero. That statement is true, so I'd put my Batman object, whatever I call it. I could call it Batman if I wanted to. I would put him or construct him in regards to the blueprint for a superhero. Fallout is a video game. I would use my Fallout object. What template would I use? I would use the video game template or the video game blueprint. Your Honor is a TV show. Wool, the Silo series, is a book. All of these objects belong to different classes because it follows the is-a relationship. Now, your classes should always be public. So let's switch over to VB and take a look at how to create a class header, which is the name of the class. When you are creating a class, they should always be public. So we start with that word public. We are creating a class. Now we give it a name. So we add superhero, because Batman is a superhero. Maybe we create another class, because Batman is not a video game. He is a superhero. So I create a separate class, video game. Maybe I create a third class called dog. Batman is not a dog. He is a superhero. So we want to make sure when we're creating objects, they go to the right blueprint or the correct class. Classes are blueprints. Now, each class contains its own set of attributes, which we'll go over in a minute, and constructors. All of these contain these attributes, constructors. Video game also contains attributes and its own constructor or constructors. Dogs, they have their own set of attributes. or constructors as well. Every class will always have these, as well as other methods that allow your object to do something or to access values of those attributes. When you create an object, the programming language will want to know what class you are using. So the computer wants to know, okay, what blueprint are you using for this object? Which blueprint am I accessing so I know what attributes to give this object? Because remember, each class is going to have its own set of attributes. What template do you want this object to have? What constructor should I use? What methods is it going to have? That's why we have those classes. They are the blueprint, and by writing a specific line of code, we can give that object access to the blueprint, which is the class. Now, creating an object goes inside your main program class, not the class for the object. You're able to do it outside the class, and you want to do it outside the class. Your class should have attributes, your constructor, and methods that the object can access. Now, without an object, you're not going to be able to access those attributes. Those attributes are tied to an object. They are not like global variables. You want to access those methods in the class? You have to do that with an object. Now, you may hear some terms or phrases, especially in the beginning. I don't know why people make it so complicated when they're teaching others. They'll say things like, oh, in object-oriented programming, all you're doing is creating an instance of the class. Or they'll say things like, well, just instantiate an object. Or I've even heard the term, just invoke the constructor of whatever the class name is, class. Well, what does that mean? For anybody who's beginning, they don't know what that means, so I'm going to make it very easy to understand. All these ways that all those phrases you hear are just a fancy way of saying, hey, we're going to create an object and we're going to use a specific blueprint or class. That's what it means. So don't be intimidated when people start throwing out these fancy terms, I guess to make themselves feel better or smarter. I don't really know why they do it, but I see it all the time. I hear people say it all the time, and they feel so, proud of themselves. Meanwhile, the person trying to learn has no idea what they're talking about. I don't want to do that for you. I want to make it crystal clear and just easy to understand. That way we can all grow in our programming skills. Now, let's swing back over to VB and let's create an instance of a class. Let's instantiate an object. Let's invoke the constructor. Let's create an object using a specific blueprint or class. Once you have your blueprints or your classes set up, it is time to create your objects. Now, these classes are very bare right now. We're going to add to them in just a little bit, but you're going to create it just like you would anything else. You're going to do dim. Then you're going to give your object a name. So maybe I do this superhero 1 as new. When I use that keyword new, that tells the computer, okay, I'm creating an object. I'm calling it this superhero 1, and I'm doing it as new. That means I need to call the constructor. The next thing the computer wants to know is, okay, what blueprint does this superhero 1 belong to? What blueprint or which class do you want me to use that has the constructor that will build this superhero? So I do this superhero. That means it's going to invoke the constructor, which is a fancy way of calling the constructor that will build this object, and that constructor that I want to use belongs to this superhero class. Maybe I do another one called dog. This dog 1 as new. I need to call the constructor. I'm creating an object. The computer wants to know, okay, which class do you want to use to build this dog 1 object? And I do dog. This is what they mean when they say instantiate an object, create an instance of a class, or to invoke the constructor. These simple lines of code are what they mean. Now, these classes are very bare. We're going to add attributes and constructors and tie all of this together so you can see exactly what is happening. But let's move on to the next term. We said that your classes have attributes and instance variables that are tied to the object. Now, instance variables are something you need to know. Now, if you're in the Cambridge Computer Science 9618 course, they're going to refer to these on the exam as properties. Now, your instance variables, or as Cambridge refers to them as properties, these are things the object has and are included in the blueprint, which is the class, which is the template for the object. Now, every object is independent of another and has its own set of instance variables. Even down the road later, if you create an array of objects, each object is independent of another. Now, if you're not using object-oriented programming, if you want to store 10 names, you would need an array. Hopefully you wouldn't use 10 different variable names. In object-oriented programming, we can create 10 different objects, and each object would have their own name, and the attribute would be called the same thing across each object, but they're not related. So if I have 10 different objects where each object has a name, I don't have to keep track of the index number. I don't have to say, okay, index 7, which one was that? Because they're all independent of one another, even though they're using the same attribute name. That doesn't mean they're accessing the same one, they just have the same name. Object1.name has nothing to do with object2.name. They're independent of one another. Now, objects follow the has a relationship. So earlier, you may have asked, why did you use this superhero 1 instead of Batman? Well, Batman is the name that I would choose to use as a variable or as an object name. The user would never see that. So what I would do is I'd give my superheroes attributes. So this superhero 1 has a name, they're going to have a height, and they're going to have a specialty. This superhero 2, which has nothing to do with this superhero 1, also has its own name, its own height, its own specialty. Now these attributes should always be private. So let's swing back over. Let's talk about where the attributes go, how to make them private, and how they're tied to each object. So we have two superheroes, this superhero 1 and this superhero 2. Each superhero has its own set of attributes. Now, attributes are always private. So we type in the word private. We don't use dim because we're not creating a variable, we're creating an attribute that is tied to the object. Private. The next thing I do is I give it a name. So we said they each have a name, and we do this as string. The only difference is you're still creating the data type, you're still giving the name. The difference is instead of dim, you're using the keyword private. Now, if you're in Java, you're also going to use the keyword private, and you're going to create a variable, or excuse me, an attribute, just like you do a variable. We said they also have a height. I'll do that as an integer. And we said they also had a specialty as string. So just like that, we have the attributes. Now you may be saying, well, a video game has a name. Yes, it does. So let's do that. Let's do private name as string. You may say dogs, they also have a name. They sure do. Private name as string. Now you might be saying to yourself, well, what does it matter? Why can't I just put name wherever I want to? Because you want to follow the is a relationship. But why is that so important? Well, a dog has a specific breed. So I can do private breed as string. Superheroes don't have a breed. Now you can get technical and say, well, there are different species of superheroes. That's fine. We're not talking about that. We're just talking about you want to keep everything together where it goes. Video games, they have a price. Superheroes don't cost money. If you want to read about them in the comics or you want to see them in the movies, yes, that costs money, but the superhero itself doesn't cost money. So that's why you want to follow the has a relationship. Let's take a look at an example with my two dogs and how their objects and the attributes they would have if we use them in a program. So I would like to clarify my statement. My dogs are not objects. They would be objects if I was to write a program about them. So we have two different dogs here, two different objects. So the object is the dog. It's going to belong to the dog class. Now, each dog has its own name, its own breed, and its own age. So for this dog, I'm going to call this object this dog one. Now, this dog one has a name. His name is Albus. He's an Australian Shepherd. That is his breed. He also has an age, and at the time this picture was taken, he was 3 years old. He's a little older now. This is a separate dog. I'm calling this object this dog 2 that belongs to the blueprint or the class dog. That is going to use the same attributes, but it's going to have its own set of attributes. It has the same attribute name called name, breed, and age, but this object has its own set and its own set of values. For example, its name is Tonks. It's also an Australian Shepherd, and it's also the age of 3 because these two dogs are brother and sister. In the background, we have a third dog. Its name is Luna. She's a Border Collie mix, and her age when she was still with us was 15 years old. So let's move on to the next part. Now, the next part is the constructors, which are called, or if you want to get fancy, you can say invoked when you create a constructor. Now, or when you create an object, excuse me. The constructor is a method that is called when you write a line of code that creates an instance of a class, a fancy way of saying creating an object. It uses that keyword new. Now, this method does not have a return type. It is a special type of method. So you also do not include the keyword void for your constructor. So if you're in Java, usually when you have methods that don't, or not usually, when you have a method that doesn't return a value, you use the keyword void. In your constructor, you do not use the keyword void. So in VB.NET, the constructor is always public sub new. In Java and Python, it's always the name of the class. And in Python, when you do it, you do the definition of underscore init, which stands for initialization, underscore. Then in the parameter, you have the self parameter. Now, you can have multiple constructors in the same class, although it is not required. They must have a different set of parameters. Now, they can have the same number of parameters. Now, they do not have to, but the order of the data type of parameters cannot be the same, and I'll show you what that means in a moment. Now, constructors are used to actually construct the object. If a constructor has parameters, they are usually used to set the values for the attributes the object has. Now, a constructor can also set default values so the attributes do not contain a null value. So let's swing over back to VB. We're going to make the VB constructors for each class because each class has its own constructor that acts differently with or without those attributes. So let's take a look at what that means. So I have this dog 1 and this dog 2, which belong to the dog class. We need to create a constructor. That way, when these dogs are created, we can assign some values immediately to these attributes. So I'm going to do public sub new. When I use the keyword new here, it calls this constructor. But how does it know which constructor to call? Based on this class. So I just do public sub new. Notice this public sub new, this constructor, has 2 references. That's because this dog 1 calls this constructor, this dog 2 calls this constructor. How do I know this constructor is being called? Because there are no parameters here after this dog 1 as new dog. There's no parameters here. And there's no parameters when I call the class here for this dog 2. Now I can create another constructor if I would like. Public sub, it's going to have the same name, but it has to have a different set of parentheses. If I leave it the same name, it's going to say, hey, you can't do that. You already have one. So I'm going to pass those values. So I'm going to do by val in as string. This first letter parameter matches name, and that's common practice. One common way to pass parameters to your constructor is by using the first letter of your attribute name. So the next one would be B. That would be for breed. The last one would be A, and that would be an integer. Now, does it have to be in that specific order? No, it doesn't. But why would you make it more difficult for yourself? Just keep it in the same order. That way you know you have everything. So I'm going to say that dog's name is equal to that parameter in. That dog's breed is equal to the parameter B. and that dog's age is equal to the parameter A. Now, notice there are 0 references. If I want, say, this dog too, Tonks, to use this constructor, well, I have 1, 2, 3 parameters. That means I need 3 things in parentheses down here. So the first one is her name. That's the NS string. That's going to be Tonks. She's an Australian Shepherd, and she's about 5 years old at the time of this video. So now notice our default constructor, which has no parameters, has 1 reference. That is from this dog 1. Our public sub new with parameters has 1 reference, and that is this dog 2. Now, this is very important. If you create another constructor, it can have the same amount of parameters, but it cannot be in the same order. Maybe I can do this, which is a little different. I can do public sub new, and I can do by val A as integer, by val in as string, by val B as, keep it uniform, B as string. That is allowed. What is not allowed is to use the same data types in a row. So if I do public sub new, maybe I want to do last name followed by first name followed by age. So now the computer doesn't know what these parameters represent. So if I do breed first followed by name, if I do by val B as string, by val in as string, I'm doing breed followed by name followed by age. And I have in sub, and it says, uh-oh, you can't do that. Right here, it's saying that these have multiple definitions with identical signatures. And that's what we call this when we have a set of parameters. We call that a signature. So they need to have different signatures. So this will not work. So we're going to get rid of that. So our program gets rid of the red lines, and they can compile. But every time I create a dog object, I have to ask myself, okay, do I want to use the default constructor, which accepts no parameters, or do I want to use one that uses parameters? Now, if you don't know the values, then what you may want to do is give default values to get rid of all the null values. So maybe I do name as none, placeholder. I could do placeholder. I could simply do this. That would be fine too. Breed. Maybe the breed is blank. Age. I can put a -1 to represent that it doesn't have one. I can put a space in here. I can put in/a for not available because I don't have a breed or a name yet. So now when this dog 1 calls this default constructor, it now has its own set of default values. That is not required, but it's something that does come up on the Cambridge exam every once in a while. So this is how you use constructors. You don't have to create multiple. Again, you do not have to do that. It's just showing you one way of using constructor with parameters and one way of using it without parameters. And yes, they do have the same name, but a different signature. In object-oriented programming, you'll see the words public and private, and they do make a huge difference. All your methods in a class, they should always be public. If they are private, you're not going to be able to access them from outside of the class because they're private. This means the object cannot call them from your main program class. So you're not able to do anything with those methods. Now your attributes, on the other hand, they should be private. Well, if methods need to be accessed from outside the class, how do I access the attributes if they're not public but they are private? Well, you use set and get methods which allow you to access those attributes. Well, if I'm just going to use methods, why do I even need to make them private? Well, this is to enforce what is known as encapsulation. This means all your attributes and the methods of an object are contained inside of a single class. Attributes being private prevent code from outside the class changing the values like we usually do for global variables, can allow us to validate inputs and make our code more organized, and makes it a lot easier to read. So if attributes are private, how do we set them and access them? Well, it's a set of value, assuming it has not been done by the constructor, and we get, as programmers, choose whether it does or not. We use a public method called a set method. If we want to access it to see its value, we use a function known as a get method. This returns the value of the instance variable or the attribute to our main program so the user can see it or so we can do something with it. Now, every attribute has its own set method and get method. Now, you can also build a string that contains multiple attributes that get returned in a single return statement. You can't return multiple values. You can only have one return statement, but you can build a string, however, that builds onto itself multiple values. This is usually called a getDetails method that returns all details. Let's go ahead and take a quick overview at set and get methods. Inside the dog class, I have my set methods and I have my get methods. I can set the values for each attribute. I can also get them and output them or do something with them if I would like. Now, every class needs its own set methods and their own get methods. If I wanted to get the superhero details, I'd put set methods or I would put get methods in there. But usually you're going to have set methods and get methods because Albus, his values weren't set by the constructor, so I'm going to use these set methods. I have one for name, which accepts a parameter, sets it to name. I have one for breed, which assigns the value to breed. And I have one, a parameter A, which assigns the value to age. But how does the program know which dog object to set it to? It just says name equals in. It doesn't say this dog 1 or this dog 2. In order to access these methods, I have to have an object. And I'll show you how I call it in just a minute and how it knows which value to set and which values to return. Your get methods always start with the word get name, doesn't not accept a parameter, and we simply return the attribute. We return name, here we get the breed, we return breed, here we get the age, we return the age. Now, I also said you can build a string to return all of them because I can't return multiple values here. So I create a string called details, and I start with name and I get the name. Then I put a new line because I don't want it all on one line. For me, I don't think that looks nice and neat, so I want to put it on a new line. So I create a new line, I put breed, put a space, and I use my get breed function. Put a new line, age, and I call my get age function, that get age method. So right here, you'll also notice this is private just for a moment, and how you cannot access private methods. Here, I'm able to set the name, the breed, and the age, but this get details will not work. But if I change it to public, I can now access it from outside the class, and now that red line is gone, which means my program will compile. Let's go ahead and run this so we can see how it works. You can see it has his name, his breed, and his age. It is the objects that allow us to call these methods with these parameters. If I just try to call set name with a value, it doesn't know what object you want it to go with. So it's the objects of the class that allow us to call these methods. Now make sure when you're doing get details, you want to output that with a console.writeLine. If it just returns the values and you don't output it, nothing's going to happen. Now I did not like the format of that output, and you can see right here I put a space after breed and one, or right before breed and right before age. I don't want to do that. I want to keep it looking uniform. So let's go back and let's take a look at some last minute tips so you can get started and feeling more confident with object-oriented programming. So some last minute tips before you go. Like anything, the more you practice, the easier it becomes. Anything is difficult at first. I mean, think back to when you first started loops or writing your first method or your first bit of complex code. Of course, it's a lot easier today because you've been practicing. And as you practice, it becomes easier. Now, practice doesn't make perfect, but it does build consistency in what you're able to perform. Give your coding skills and yourself a chance to develop and grow. Don't think you're going to be able to sit down and do this in one afternoon, but as you do it more and more and more, it becomes a lot easier, and you can simply write that program, whatever it may be, in a short amount of time. Now, you can do this, so make sure you keep at it. Everybody is capable of doing this, including you. Now, you can always ask me questions by posting a comment below. I do try my best to read all of them. The only time I don't is when I don't know there's a new comment, but usually when you post a comment or a question, if I'm able to answer it, I do. I hope you guys found this video helpful. If you did, please take a moment to give it a thumbs up and subscribe to help the channel grow, and we'll see you guys in the next programming video.